Thank you for coming back for our chance to finish talking about a convex mirror. We created this diagram in the last session, and now I'd like to look at a couple of calculations. Now, we've already mentioned our magnification calculation. Magnification is equal to the height of an image divided by the height of an object, or it could be equal to the negative of the distance to the image over the distance to an object. All right, let's check and see if those two values seem to be the same for this particular diagram. My height of my object seems to be 7, the height of my image, and actually I want to work this backwards. Let's see if our diagram was any good. Okay, we'll use the assumption that the formula works, and we'll check and see if my height works out, because right now my height looks to be just over 3. Okay, so if I'm trying to find the height of my image, that means I'm going to multiply the height of my object over here. So the height of my image is going to be equal to the negative of the height of my object multiplied by the distance to my image over the distance to my object. And I just brought the negative sign out front. Well, we need some more measurements. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the distance to my object is equal to 10. The distance to my image, and here's where I've got to take this with a grain of salt. And that's, we'll use what we have here. 1, 2, 3, 4, 5. Now, the distance to my image is actually equal to -5 because it's in the virtual world. And we have the height of my object was 7. So let's see how this turns out. We've got a -7, and I'm not going to put units on this because these are boxes, not meters or centimeters. It could be done in centimeters, could be done in millimeters, inches, anything as long as everything was the same. The distance to my image is -5, and the distance to my object was 10. That's a -1/2. So this looks to me like a negative of a negative. 7 times 1/2 is 3.5. It looks a little shorter than 3.5. In other words, maybe I should have drawn it to where the parallel ray crossed my mid ray, the one aimed at the middle point, and I didn't label that before. That's my mid ray, the one that aims at that perpendicular spot which is along my central axis. Okay, which, by the way, this is one of the most reliable rays that you have. Your parallel ray, even though it's way the heck out here, is also one of your very reliable ones. Now, I want to double check that we put this in the right location. And to do that, we're going to have to introduce our other equation. Our other equation is that 1 over the distance to the object plus 1 over the distance to the image is equal to 1 over the focal length. And I want to check the distance to my image. All right? So to do that, I'm going to subtract this one off. So 1 over the distance to my image is equal to 1 over my focal length minus 1 over the distance to my object. 1 over my focal length is 1 over my 1, 2, 3, 4, 5, 6, 7, 8, 9, -9 boxes out to my focal length, minus 1 over the distance to my object. That's 1 over 10. And that's a positive 10, so they're both negative. So I'm not going to try to do that by combining things up. I could if I wanted to, but that sounds painful. Let's see, so I'm going to put in a -9 and hit the inverse key to make it 1 over -9. And I'm going to subtract. I don't need to get fancy with that. That's 0.1. And from that, I get a negative 0.21. And I'm going to take the inverse of that, because 1 over the distance to my image is equal to negative 2.1. So the inverse of that answer is that the distance to my image should have gone to a point that was negative 4.7. Now, that's very, very close to where I put it at negative 5. Had I used negative 4.7, it would have revised this one a little bit. I'm curious. I'm just going to change that to 4.7 there and see what that comes out to be. So that would be 7 times 4.7 divided by 10. And it should have been, in reality, this one leads to a height of my image of 3.3, which I feel a little bit more vindicated because that's closer to what I actually did. All right. Now, sketches are very good approximations of the calculations. These are the calculations. Okay. I should have solved for the distance to my image first with my mirror equation. This also later on gets named the thin lens equation. And then from that, I should have been able to figure out what the height of my object is by using my magnification equation. All right. Sketches are for sketches. They are for approximations of correct answers. They are not for exact values.